Hello everyone, welcome to Dakshana e-classroom program. In today's lecture, I am going to discuss the solution of all the problems asked in IIT previous year IIT papers based on chapter relative motion. So before going to start the solution, let me tell you something else. Like this chapter relative motion, many students find it little bit difficult. Questions like if you go for a simple question, definitely they will be easier, but very good questions can be even formed from this chapter. We will see that even IIT has asked also some good questions based on it. Another point is that yes, it is true that IIT do not ask frequently or do not ask questions from this chapter too much frequently. It asks sometime, I mean like rarely even, but whenever it asks, a good question come from this chapter actually. So that's why it's important to understand the concept, the things like how exactly we deal, how different types, different good questions can be formed. So learn the approach, learn the concept of things that has been asked from this chapter. So let me start with the problem number 1. So let me read it. Two stones are thrown up simultaneously from the edge of cliff to 40 meter high with initial velocity of 10 meter per second and 40 meter per second respectively. Which of the following graph best represent the variation of relative position of second stone with respect to first stone? Assume stone do not rebound after hitting the ground and neglect air resistance. Take the value of G is equal to 10 meter per second square. So these are four options given, and let me first explain you the question what exactly it is saying. So it is saying from a building of some height, this building to 40 meter height, two stones are thrown. Let me say stone 1 A or stone 1, stone 2. One with the velocity 10 meter per second and another with the velocity of 40 meter per second. And what will happen actually? Definitely these two stones are thrown simultaneously. So what will happen? Initial velocity of this is higher, so it will move faster, it will move slower. So there will be separation will start. Initial separation is 0, so separation will start from 0, but then separation between these two stones will start increasing, and that separation we need to plot with time after starting from t is equal to 0 to the time final, means when both these stones are hitting the ground. Another assumption we need to take is that assume stones do not rebound, means it is not bouncing back from the ground once it hit the ground. So that is the problem. Let's see. So I am taking now, let's see this stone position of this particle. So what I will take, this I am taking y positive direction, this will be negative direction. A, that will be minus 10 meter per second square, that is equal to G actually. So now for stone 1, let me write its position first. So u1 is how much? 10 meter per second. A1 you can write minus 10 meter per second square. Then y1 can be written as 10t minus 5t square. This is the position of stone 1, function of time. Similarly for stone 2, so I can write exactly u2 will be 40 meter per second, a2 will be same minus 10, then y2 I can write directly, it's 40t minus 5t square. This is the position of stone 2 at any time t. Now it is asking variation of relative position of second stone with respect to, so relative position of 2 with respect to 1, means relative position of stone 2 with respect to 1, that I can write, let me write as 2 1. So that will be equal to what? y2 minus y1. Simply this minus this, I will get simply 30t. So ideally, if I just blindly go from this step, then the graph should be simply this straight line, but that will not be because it's not complete. Is it? We need to look for something else. Is it? Because this is IIT question, so I Actually, it's been asked in 2015 mains, so not even like advanced, but it's good question actually. So here, this is the relative position, but we need to look for few more details in this question actually. So first thing is, first stone will hit the ground. Let's calculate when it is hitting. Then second stone will also hit the ground. Let's calculate that time. Because ultimately once both the stones are hitting the ground, then there is the relative position between them will be 0. But we need to look for relative position till the time both the stones are hitting the ground. Is it? So let me first calculate time to hit the ground. Time taken by particles. So 1, then I can write y1 is equal to 10t minus 5t square. When it is hitting the ground, y1 will be displacement, position of particle 1 will be what? Minus 240, is it? So minus 240 equal to 10t minus 5t square. Simplifying and dividing, it's t square minus 2t minus it's 48 equal to 0, right? And this comes out, just dividing it by 5, so it will be 1, it's 2t, and dividing by 4 and it's 8, yes. So then t we are getting actually 2 plus minus under root 4 plus 4ac and 192 divided by 2, and simplifying it t, because it will be definitely greater than 2, so negative sign cannot be possible because time will not be negative. So I am getting it 196, that will be 14 plus 2 divided by 2, it will be 8 seconds. So this is the time when stone 1 will be hitting the ground. Similarly, time is it by particle 1 hit the ground. Okay, similarly, time to hit ground for particle 2, right? So for y2 also it will be 40t minus 5t square, and when this particle hitting the ground, it will be also origin, so it will be minus 240, right? So minus 240 40t minus 5t square, again rearranging it, it comes t square minus 8t minus 48 equal to 0. Similarly, solving for this, it comes 8 plus minus under root 64 plus 192 divided by 2, that comes 8 plus minus 16 divided by 2, again negative will not be there, so it comes out to be 12 seconds. So 12 seconds is the time when both the stones will be on the ground, and after that story will be over. So now we need to let me erase this part, I need space. So options I am leaving still there. Okay, so we got it up to here. So now we need to check the things according to this, because up to 8 seconds both the particles are in air, so relative position can be written with this. After 8 seconds, from 8 to 12, one particle will be on the ground, second will be on the air, so then relative position will be something different, is it? So let me just so up to t equal to 8 seconds, both particles are in air, right? So relative position can be simply 30t for t less than equal to 8 seconds. Then position, I mean like the graph will be simply straight line. This is S, relative position 2 1 versus t up to 8 seconds. So it will be simply straight line up to 8 seconds. Clear? Then after 8 seconds, what will happen? After 8 seconds, this particle will be on the ground, is it? So for t greater than, can write t greater than 8 seconds less than equal to 12 seconds, particle 1 will be on the ground. So the situation will be like particle 1 has landed here, We can even check where is the particle 2 at t is equal to 8 seconds. If I am substituting it here, so it will be 320 minus 80, and that comes out to be 240. So actually at that moment the particle 2, this has hit the ground, and the particle 2 will be here, right? Because you can see the position of this particle. So definitely at t is equal to, I can check it here also, at t is equal to 8 seconds it will be 240. So the separation between them will be 240, means particle 2 will be here, it has come down here, and particle 1 has already landed at the ground. So now this will be simply at rest. The position of this particle will be simply like the separation, is it? So it will be starting from starting from 240. Now it will keep on decreasing. I hope you are understanding the point. So now for t, then I can write the particle 1 is on ground and S21 is simply given by y2, and that is equal to 40t minus 5t square. But remember that it's not valid for t less than S12, it's only for this interval. So now I can get S21 is equal to simply 40t minus 5t square. Just I need to plot how it looks like for this, is it? So how it will be definitely a parabola, and the coefficient of this is negative, so definitely it will be how much? Maxima. So maxima means it can be only like this, and when it is finally coming to 0, is it? Finally, like when this particle also landed to the ground, both particle will be on the ground, relative separation will be 0. So then you can see after that it will be like maxima. So graph will be something like this, and this is the 12 second. And now we can check which option actually matches. So definitely not, this is our correct option, and the maximum separation also we can write it's 240 meter per second. This I am trying to explain you everything, like, is it, from in detail. In exam you can like just look for the possibly correct option, okay, like this is all right, means up to here all graphs are same. You can just look for next from 8 to 12 second what is exactly happening. You can eliminate parabolic graph, you can directly mark it actually, and maxima. But this I am explaining you things in deep detail so that you can learn the things from this part, okay. This like things asked in this manner, this type of problem we need to deal, we need to proceed in this manner. That is the approach, you should learn the approach actually, that is the point here. So I hope you are clear. Simple thing here, two particles are projected from here simultaneously with different velocities, right? And it's asking the plotting the variation of separation of particle 2 with respect to 1, is it, up to final moment. So things are changing actually. Separation you can get it hit this, but this is not the final result, because particle 1 will be hitting the ground at 8 seconds, 2 will be hitting the ground at 12 seconds, and from 8 to 12 seconds things will be different. That you need to take care properly. So that we just looked it here and then plotted the graph for each, is it, interval of time, and this is what we are getting. So the answer finally coming is B option. That's up to this problem. Okay, see the next problem, question number 2. So airplane A and B are flying with constant velocity in same vertical plane at angle 30 degree and 60 degree with respect to horizontal respectively as shown in the figure. So two airplanes flying in the same vertical plane at angle 30 degree and 60 degree with the horizontal like this, and given in the speed of plane A. So speed VA is given as 100 root 3 meter per second, and at t is equal to 0 an observer in A find B at a distance of 500 meter. This observer, so observer in A find at t is equal to 0, observer in A find B at a distance of 500 meter, means this separation is given as 500 meter. Okay, so at t is equal to 0 an observer in A find B at a distance of 500 meter. We need to understand its meaning also properly. That means initially the separation between two planes, aeroplanes or airplanes, is 500 meter. this observer means observer in A sees B moving with constant velocity perpendicular to the line of motion of A. That is also. Then at t is equal to t naught, A just escaped being hit by B, then you are asked to find the value of t naught. So this is the problem. Let me solve it. So first is I can write the separation between two airplanes A and B, that is equal to 500 meter. Okay. Another thing is it's saying observer this observer means observer in A sees B moving with a constant velocity perpendicular to the line. This is quite important point here. So what it means exactly, you need to understand every point clearly. So one thing is this is the motion of A and that is B. Okay, so this is 60 degree and this is given as 30 degree. Now here I can draw one line which is parallel to this. So let's say this is a line which is parallel to A, is it? Let me write it B prime. Then this angle will be how much? 30 degree. So this velocity of A is given as 100 root 3 meter per second. Let me write velocity of B is VB. Then component along this will be VB cos 30 degree. Along this VB sin 30 degree. Now see, look at it. This observer sees B moving with constant velocity perpendicular to the line of motion of A. What it means? This means the observer A is feeling that B airplane is simply coming towards observer A or coming towards plane A. That means the relative velocity of B with respect to A is only along perpendicular to the line of motion of A, and that will also mean the relative velocity in this direction along the direction of motion of A must be 0. Then only observer A will feel B is flying towards plane A. So that you need to understand properly, then you will be, so this point, this line statement is quite important. You need to look for every statement properly in the question, because based on that we will get only condition. So from this, I mean, this means VAB is only along perpendicular, along perpendicular to direction of motion of A, right? So I can write in this direction the velocity must be same, then only relative velocity, is it? So VBA along direction of motion of A must be 0. Right? And that means 100 root 3 minus, I can write VB cos 30 degree must be 0. So this implies I am getting, simplifying cos 30 root 3 by 2, solving it, we are getting velocity of B is 200 meter per second. Clear? We already have angle, so I can get this component will be VB cos like sin 30, that means 100 meter per second. I hope you must be clear what exactly how we got this condition. This is very important, because if you are not understanding why I am writing this, how I am getting this condition, then it's not possible to understand this problem. How I am getting this, how I am reaching this conclusion, that is from this statement. It's clearly saying this observer means observer in A sees B moving with constant velocity perpendicular to the line of motion of A, means observer A is feeling that B is simply approaching towards A, right? So that means the relative velocity along this direction must be 0, and this is what relative velocity along the direction of motion of plane A must be 0. So just taking the relative velocity component along this direction and equating that to 0, I'm getting this VB is coming out to be 200 meter per second. So we got VB, then I can easily get this, right? So VB sine 30 degree, that will be equal to how much? 100 meter per second. So now another point, it's given initially the separation between them is 500 meter. Now to cover the separation between them, only velocity of approach will be required, and velocity of approach is the component of relative velocity along the line joining them. So either you can write, it will be simply this, or you can write component along this, and then getting the relative velocity. Both will be same thing actually, because this component will still like will not be along the line joining them, is it? So velocity of approach that will be, you can write it otherwise it is simply VB sine 30 degree because of according to this statement, or you can write initially at t is equal to 0, this is the separation, so you can write the component of velocity along this, is it, line joining them, and then also you will get exactly same thing. You can check the calculation, I am directly writing it. So this is VB sine t, then time to, okay, another point, it's saying at t equal to t naught, A just escape being hit by B. So for when it is like talking about just escaping, then we do the calculation by assuming that it's just hitting actually. And it's only just escaping and just hitting, there is not much difference. We take it almost equal, and we are taking like, that means it's exactly hitting it or reaching, means both are reaching at same point. So separation between them is becoming 0, right? So time to hit plane A by B, that you can write separation divided by velocity of approach, and this comes out to be 500 divided by 100, that is 5 seconds. This is the answer to the problem. So if you are understanding the language, getting it properly, I think like even language itself explain you things that what you need to do, and automatically you will get the answer. So read the problem carefully, that is also important. Don't like just take it assume okay this will be like that, because many silly mistakes we do in exams, something similar, where we do not read the question either carefully or not even read it completely. We have like a lot of things in our mind and we assume something, and then we do some mistakes. So just read it properly, take care of that, and I hope you're understanding this problem. So the main important thing is what exactly it's saying. So it's saying it's to an observer sitting in A, it's completely appearing that it's moving towards this. That is possible only when the relative velocity component along the direction of motion of A is becoming 0, and that means this quantity is becoming 0. From there we are getting this condition. And then velocity of approach, simply this. Then time taken is separation divided by velocity of approach. So then we are getting 5 seconds, and this is the answer to the problem. Okay, so the next problem, on a frictionless horizontal surface, assume to be xy plane. So this is a frictionless horizontal surface, we can assume it is a xy plane. A small trolley A is moving along a straight line parallel to the y-axis. So trolley A is moving along a straight line parallel to y-axis, so it's moving along this line with the constant velocity of √3 - 1 meter per second. At a certain instant, when the line OA make an angle 45 degree with the x-axis. OA is the line connecting with the trolley A and origin. So trolley is moving, and at some particular instant of time when OA line make an angle of 45 degree with the x-axis, so with the instant when the line OA make an angle of 45 degree with the x-axis, a ball is thrown along the surface from the origin O. Its velocity make an angle phi with the x-axis, and it hits the trolley. This is the information given to us. This problem was asked in 2002, and then two parts are given. So let's see them. So first thing is, let's say the ball is projected with this velocity of ball at an angle of phi. Within the phi is the angle if I take in ground frame. Okay, so now what, and it's given that phi with the x-axis, and it hits the trolley. and finally the ball is projected in a manner such that it is hitting the trolley. So definitely what will happen actually in this, at this moment of time, if I take this is a separation A, then this is also separation A, okay, when this is making an angle of 45 degree with the x-axis. I can write the component of this velocity along this direction, that is VB cos phi. Along this direction it's VB sin phi. If this ball is hitting the trolley, is it, velocity of trolley is only along this, that is given as √3 minus 1 meter per second. So velocity of trolley along x-axis, it's 0. So I can write velocity of ball with respect to trolley, that will be equal to VB cos phi along x-axis plus this, you can write VB sin phi minus √3 minus 1 along y-axis, right? And initially this is the separation, okay, and it is also clearly mentioned that finally the ball is hitting the trolley. So what it mean? It mean that the separation this and this must be covered by the time the ball hit the trolley. Okay, let's see the like part 1. Part A, the motion of ball is observed from frame of trolley. So we are observing in part A the motion of ball from the frame of trolley, and calculate the angle theta made by the velocity vector of ball with the x-axis in this frame. Means in the frame of trolley, A part, in the frame of trolley, it's asking find the angle theta made by the velocity vector in this frame, in the frame of trolley with the x-axis, is it, in the frame of trolley. So first thing is, it's clearly mentioned the ball hits the trolley. Ball is hitting the trolley, okay. If you look at it, this problem, is it simply, it will appear to be like complex, but if you look at it properly, like looking and analyzing the things, it will be like straightforward, you will find it easy. So now just sit inside the trolley and it's clearly mentioned to you that the finally ball is hitting in the trolley. Just look at it from practical point of view. You are standing here, okay, and if some object is moving, let's say with respect to you in this direction, is it possible in any way that this object can hit you? I don't think. Assume gravity free, like everything is in this plane. So you are standing here and object's velocity is in this direction. For you, it's never going to be like possible that this object is hitting you, right? It can hit you only when the velocity of this object is straightforward along you. I hope you must be agreeing with this condition. So now when we are sitting in the frame of trolley and it's clearly mentioned that the ball is hitting the trolley, what it mean? That mean from the frame of trolley the ball must be projected by targeting the trolley, right? So that means this moment the angle made by the trolley, made by the velocity of ball with respect to with the x-axis from frame of trolley must be what? Because trolley itself is making an angle of 45 degree with the x-axis. So if ball is projected along this direction from frame of trolley, then only it can hit the trolley. I hope you are understanding. So in that way we are straightforward getting the answer for part A, that the angle theta must be 45 degree, is it? So to hit the trolley, the ball must be projected towards trolley in the frame of trolley. That means the theta angle made by the velocity vector of ball with the x-axis must be 45 degree, because trolley is making with the x-axis 45 degree, so ball must be projected exactly pointing towards the trolley in the frame of the trolley, then only it will be possible that the ball is striking or hitting the trolley. So we got the answer, theta is equal to 45 degree. This is part A. Again, simple, don't look at it like making it complex. Simple thing, if you are like standing, if something is coming towards you, only then it is possible that object can be hit you. If the velocity of an object for you, like you may be in ground frame, you may be in some moving frame, if something coming towards you, then only it is possible, right? So if it is like from a frame, from my frame, if something object is coming in this direction or going in this at some angle, it's never going to hit me, right? If something is coming towards me, then only it will be possible that the object can hit me. Getting it? Simple thing. So if an object is coming towards the trolley in the frame of trolley, then only the a ball can hit the trolley. So means in the frame of trolley, the ball must make an angle of 45 degree, because trolley itself is making an angle of 45 degree with the x-axis. That means this theta is coming out to be 45 degree. This is part 1. Let me erase this part. I hope it makes sense to everyone. Okay, the next part it's saying is that find the speed of ball with respect to the surface, means in ground frame, if this phi is this. Okay, all right, just one second. Phi is given as 4 by 3 times theta. So first this is part B. So phi is velocity vector of ball with respect to what? Velocity vector of ball in ground frame, is it? Phi is the angle of velocity vector of ball with x-axis in ground frame. Okay, so first by this relation I am getting phi is coming out to be 4 by 3. This is theta is 45 degree, means pi by 4. This comes out to be pi by 3. So I got the angle phi. Alright, now it's saying find the velocity of ball with respect to surface. So I need actually VB, right? For this I can use one condition. The condition is that the ball must hit the trolley, so that means I can write, by the time the ball covering this much distance, the ball must cover this much distance also from frame of trolley. Alright, so the time, let's say time taken by ball to cover x component, I can add this will be like, let's say t is equal to what? A divided by, this is VB cos how much? Pi by 3, and this must be also equal to time taken to cover y component separation, and that is equal to A divided by VB sine pi by 3 minus root 3 minus 1. It means these two things should be equal, and that implies A by, if I substitute it here, VB cos 60 by 2 must be equal to A divided by VB root 3 by 2 minus root 3 minus 1. Just A cancelling out and rearranging it, this implies I am getting VB root 3 by 2 minus root 3 plus 1 is equal to VB by 2. Taking LCM, so 2, this is 2 and this 2 cancelled, right? And then rearranging it, this implies VB. Taking it this side, it's root 3 minus 1, and taking this term that side, that will be root 3 minus 1 into 2. This getting cancelled out. We are getting VB is coming out to be 2. This implies VB is equal to 2 meter per second, and VB is what? Velocity of ball in ground frame, and that is the answer. So to find the speed of ball with respect to the surface, means that is coming out to be 2. Logic is that I calculated the angle phi, I applied from this frame it will be finally hitting, because this is the information we have actually. No other information is available to us. So I'm observing things from the frame of trolley. I know it is finally going to hit the trolley. So that means by the time ball cover x component of the distance, it must cover this separation y component also. So I calculated the time and just equated that, because same time it is going to hit me. So in same time it will cover this much distance, x component and y component, making them equal, and just simplifying, a is simply getting cancelled out, and solving it, we are getting the value of speed of ball in ground frame, that comes out to be 2 meter per second. This is the problem number 3 that is asked in 2002. Okay, next problem is, it's a assets